Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is particle size distribution as per USP 786 chapter. Particle size distribution, which is also called as sieve analysis, is used to classify the powders or granules based on its sizes. Let us understand the detailed prescription of pharmacopoeia. Particle size distribution, that is PSD. It is a method of classifying the powders or granules by particle size distribution. In this technique, the powders or granules are separated by individual definite sized sieves and estimate the distribution of the product powder characteristics. Mechanical sieving technique is suitable for powders and granules with a size of more than 75 microns. This is a simple grand mass technique for separation of various particle sized materials. For particles of higher density and size higher than 75 microns, this technique is useful. Generally, product with smaller size of lower than 75 microns, the density will be very low and has a tendency to stick closely with other particles, making it difficult to sieve. Other suitable techniques using air jet may be suitable for classifying such powders. This technique works well for free-flowing dry powders. Such powders pass through the sieves very easily. The relative humidity RH should be controlled at lower percentage, that is at about less than 60%, while carrying out the sieve test to avoid absorption of atmospheric moisture. This is important. If there is higher amount of relative humidity, the particles tend to stick to each other, making it difficult to pass through the sieve. The sieves. The sieve numbers are derived from the number of apertures per unit length, that is 1 inch, at any place on the round sieve container. The sieve numbers are derived this way. You may count number of squares per inch on different locations of the sieve and you will be surprised to see that this matches. Physical checking of aperture per inch may be possible for lower mesh numbers than the 60 number mesh. This is because the number of apertures is more, and with naked eye the aperture per inch could be counted easily. With magnifying lens, it may be possible to check for few more sieves. Probably by using a magnifying lens, few more sieves may also be checked. For mesh numbers 170, 200, 230, 270, 325, it may not be possible to check physically. For all these sieves, it is practically impossible to count. Handling of sieves. The test sieves must be handled carefully to avoid any damages, that is holes or loose edges. Sieves are very sensitive equipment. The results obtained using damaged sieves are doubtful and unreliable. So it is necessary to keep the sieves in good condition always. It is also necessary to check the material of construction of the mesh of the sieve. It should be at least SS 314 grade. Mild steel meshes should not be used. They can rust and the aperture size may vary significantly after certain use. The sieves should be cleaned with air jet or liquid stream. After analysis, it is easier to blow air through the sieves to clean it from remnants of the previous product. Water wash can also be done in case the remnant particles are water soluble. Gentle brushing may be done in case of any material sticking in the sieve apertures. This can also be done if the sticking material could be cleaned off with a mild brushing. After cleaning, drying by air, the sieves should be stored in their original container, well protected. This is important. As told earlier, the sieves are very sensitive equipment and should be treated carefully. After washing, the sieves should be placed firmly in a clean LDPE bag within the original box of that sieve. The sieves should not be hit hard or dropped on the floor. Never use spatula or any other sharp items while handling the sieves. These kind of sharp items would have abrasive effect on the sieves leading to damages. Test specimen. Between 25 gram and 100 grams of the material should be taken if the individual monograph does not specify the amount to be taken as test specimen. Optimum amount of specimen may be derived after a couple of trials. 200 mm diameter sieve should be used for the test. This amount between 25 grams and 100 grams is for 200 mm diameter sieve. A smaller sized 76 mm sieve may also be used for testing. In such case, the amount of specimen taken should be 1/7 of the amount that was used for 200 mm diameter sieve. 0.5% of antistatic agent like colloidal silicon dioxide and or aluminum oxide should be added for any potential electrocharged materials to avoid any adverse impact on the testing. Certain materials do have some electrostatic charges. This would make the particles stick to each other and to the mesh apertures also. So some amount of antistatic agent is required to be added to make this sieving technique successful. There should not be any agglomerates or lumps while carrying out the sieve test. So before carrying out the test, it is necessary to see that there are no hard agglomerates or lumps in the specimen. Testing. Powder agitation devices are used for testing. This is the basic technique. Mechanical agitation methods will induce either a vertical oscillation or a horizontal circular motion or tapping or a combination of tapping and horizontal circular motion. There are variety of sieve shakers like Rotap, Cole Palmer, Rich, etc. working with this principle. There are electromagnetic sieve shakers also available with the same principle of working. The test sieving analysis is supposed to be complete when the weight on any of the test sieve does not change by more than 5% or 0.1 gram of the previous weight on that sieve, that is on 200 mm diameter sieve. This point should be noted. The end point is considered complete when the difference between two weights after each operation should not exceed 5% of the previous weight or 0.1 gram on the same sieve. This is similar to constant weight in LOD test or sulfated ash test. That means when the previous weight is say 5 grams, the second weight after sieving for another 5 minutes, the value should not change by more than 5%. That is 5% of 5 is 0.25. So the second weight should not be lesser than 4.75 grams. This is on 200 mm sieve. The acceptance criteria for a 76 mm sieve is not more than 10%. For smaller sieve, the value is not more than 10% calculated in the same way as explained above. If less than 5% of the total sample weight is present on any sieve, the end point of completion of test will be not more than 20% of the previous weight on that sieve. This is another case. For example, if 5 grams of total sample weight is present on any sieve, the end point is 20% of the previous weight. That means 20% of 5 is 1 gram. The second weight should not be lesser than 4 grams. That is 5 minus 1. If more than 50% of the total sample is present on any sieve, the test should be repeated, including a mesh in between the sieves carrying the excessive weight and next coarser sieve in the nest. In this case, for example, if more than 50% of the total specimen weight is found on the 63 micron sieve, the 75 micron sieve should be placed between 63 micron and 90 micron sieves in the sieve nest and repeat the test. Sieving methods. Place accurately weighed amount of sample on the tailed coarsest sieve of the nest. Make sure that the sample does not pass through the mesh before setting in the nest. When weighing on coarser sieve, some amount of material may pass through the mesh even by a gentle vibration also. Set the nest on the sieve shaker, rotary or tapping of a combination, and agitate for 5 minutes. Carry out the test as recommended for 5 minutes. Carefully take out each sieve and weigh again. So carefully take out each mesh from the nest and weigh accordingly. Repeat the setting and agitation process until the endpoint criteria is met. The test has to be repeated to achieve the endpoint as explained in the previous slide. Reconcile the weights of the materials. Reconciliation of weights must be done. The reconciliation example is given in the next slide. Total loss should not be more than 5% of weight of the original sample. After reconciliation, the loss should not be more than 5%. In the example in the next slide, the total weight taken was 30 grams and reconciled amount is 29 grams. 5% of 30 grams is 1.5 grams. The reconciled amount should be within 1.5 gram from the 30 gram quantity. That means the minimum reconciled amount should be not less than 28.5 grams. Reporting of results. This is a fabricated data sheet using mesh numbers 40 to 120. Percent weight retained will be each individual retained weight divided by the total, that is the 29 grams. Cumulative retained material is a simple arithmetic addition of previous value to the next value. Cumulative passing value is 100 minus each cumulative weight retained. Very simple calculation. Other important points to note. The test sieves must be calibrated using microscopic method or using standard glass beads. Standard glass beads of various sizes are available for calibration. The calibration should be carried out as prescribed by the standard glass bead supplier recommendations. Alternatively, microscopic measurement could be done using a calibrated scale. It is time-taking and strenuous, but it is economical. The sieves have to be recalibrated with a definite frequency depending upon the usage pattern. The sieving test method must be validated to assign the time of sieving, the amount of sample to be taken, and the time of agitation must be established by method validation using the method as prescribed in USP 786 chapter. Laser diffraction methods are also used for determining the particle sizes in lower range than 75 microns, 45 microns or below. Refer General chapter Light Diffraction Measurement of Particle Size, chapter 429. Generally, for particles lesser than 75 microns, laser light diffraction measurements method is used. This part of the PSD is out of scope of this laser diffraction method. Please refer General chapter 429 for this. On any other opportunity, I will try to make one more video on this chapter. I hope that the information on the particle size distribution is useful to you. Read carefully the entire chapter of 786 and check whether your SOP matches with these requirements. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in the comments box for any further support. Thank you.